single energy level under the removal of all degeneracy. This removal, if one energy level contain more number of energy state, then we call it a degenerate state. If one energy level contain more number of energy state at the same energy, we call it degenerate level. Degenerate level. What does it mean? If E is the energy level, okay, and it is the energy level contain more number of energy, maybe E1, E2 all have same value, same energy. So this level contain more than one electronic state, then we call it the degenerate level. If it contain not more than one electronic energy level, we call it the non-degenerate state. Non-degenerate state is the pure state. Non-degenerate states are the pure state. If we apply anything, if we apply, it cannot be further splitted. So if it's a non-degenerate state, let's n equal to 1, means for hydrogen atom, n equal to 1, energy level is 13.6 electrovolt, minus 13.6 electrovolt for hydrogen atom. This is a degenerate electronic state because it can accommodate spin up and spin down state. If we apply magnetic field, then this minus 13.6 electrovolt will be split into two energy level, below this 13.6 and another above. So you can find plus minus delta shift two energy level. So minus 13.6 electron will have two degeneracy. Degeneracy level is 2. Double degeneracy. But after magnetic field, you have this splitting. It cannot be further splitted. So these are now non-degenerate electronic level. Is it clear? And this terminology will come multiple times during my teaching. That's why I want to clarify this point. Do you have any queries?
Sir, it's clear.
Is it clear?
Yes, sir.
Well, you have to understand, you don't need to hesitate. Maybe some students understand clearly, some students have some doubt. You stop me anywhere and ask me to repeat this part. Okay?
Sir, can you repeat this real quick? I lost connection for a moment.
Which part? Is degeneracy point of view?
Yes, sir. Yes, sir. Yes, sir.
Okay. Degeneracy, just you can consider you have one energy level. Okay, you just saying, let's assume any point, hydrogen atom, H atom. You know n equal to 1 level is the energy is minus 13.6 electrovolt. Am I right?
Yes, sir.
This level, if we apply magnetic field, okay, because this here you can accommodate two electrons, one electron spin up and one electron spin down. So this level accommodate two electron means two energy level is coupled within this 13.6 electrovolt. This is we call the degenerate energy level. Rate level. If we apply some magnetic field, this will split into two energy level. Now this, if you consider this under magnetic field, under some finite magnetic field, you apply the magnetic field. Field is B. Some magnetic field we apply. So this should be splitted. So one energy level should be lower than 30.6. Under this, depending on mu B, Bohr magnetic into B. This amount it could be splitted. One should go down, one should move up. In general, as per the direction of magnetic field, its up is in the ground state, means lower level, and the down electronic level is the upper level. So this part, this splitting, now you can see, even if you apply more magnetic field, it will go down. Okay? If B is high, then this splitting should be higher, but it cannot be further splitted into other types of energy level. So it's a single energy level. Then this is called the non-degenerate electronic level.
Sir, excuse me, sir.
Thank you, sir.
Yes.
Sir, can you explain how the magnetic field splits the energy levels?
How the magnetic field split the energy level? Magnetic field, you are applying some energy. If you apply some energy, this you don't know. In general, this electron they have spin up and spin down. It's randomly moved. You don't have any control. Whenever you apply some magnetic field, as per the field constant, each have the own magnetic moment. Each have its own magnetic moment is the mu b. If I consider magnetic moment of this pin is mu b, then the energy one will gain because one will moving in one direction and other electron under magnetic field will go in the opposite direction. So for this point of view, one electron will gain energy, one will lose energy, something mu b. This point of view, if it rotate crossing this direction spin up electron, then it will have lower energy. What is the amount? This should be mu b into b amount, and the other one will gain the energy and it will move the upper level. This is called mu bb. This is a more magneton. This is something like you are providing some energy, and if this energy you provide, then it depending on your energy, if you have some spin moment, if you have some magnetic moment, this spin is nothing but a magnetic moment. If we have some magnetic moment, it could be the positive direction and it could be negative direction. If it's positive direction magnetic moment, we call it spin up. In that case, it will go, it will lose its energy from the initial level, and the other one will gain energy from that level and it will go up. Same thing. It's the same thing as the azimuthal quantum number. Whatever you are getting, ml, it's the initial level. L, you know this, the quantum number starting from this magnitude to y, it is L value. If we consider L equal to 1, then 1 should be L equal to ml value. It's split it. We are just drawing this, but magnitude is L equal to 1 is 1. It is the ml value is 0. 1 is going to here. This up gain some energy. So this ml equal to plus 1, and another one if you got ml equal to minus 1. But magnitude, if you consider this is the magnitude is 1. This is 1. This is magnitude 1. But ml, the moment it's got 1. This is 0, and this is minus 1. Same phenomenon under magnetic field. You have some angular momentum. It may be no change. It may be no change. It may change to positive direction. It gain energy from the magnetic field, and someone will lose the energy from the magnetic field. Means it's in orient oppositely. So whatever if some energy with that, it want to move opposite direction to the field. So then it have to fight with the magnetic field to reach that position. So that means you lose your energy. Then you are moving with the flow of the magnetic field. That okay, you are moving that in. So you are gaining some energy. Something if you compare, I just analogically want to explain because I don't want to know detailed mathematics, but analogy if you consider you are moving along this direction, or you stay here. Some air flowing in this direction. What will happen? You will move with this. So your initial velocity is v. So air velocity is something. If I say v0, so you can get v0. If you want to move along this direction, then this should be v minus v0. So your energy will lose. Velocity lose means your energy also will lose. Total momentum will change and your energy. So same way you can consider here. One is moving against the magnetic field. One try to move along the magnetic field. Wherever one don't want to change it, maybe remain as it is. So that the three positions can be created. One is the zero moment. Another is the additional moment than the initial value. Then other should be the other it should be gained. So this is the possibility will happen same as the spin case. So it will under magnetic field, it will in the against it, if spin up, it's against the magnetic field, so it will lose some energy, and that amount is depending on the magnetic moment of the that particular system, and magnetic moment of this mu is fixed, and mu with this was the Bohr magneton. Ub is the Bohr magneton. Ub into B is the magnitude of this energy. It will lose and the spin down will gain. So that phenomena will happen. So is it clear to you?
Yes, sir. Yes, sir. I understood that. Thank you
Okay.
very much, sir.
So that's good. So this way we can lose, because I want to do this analogical point of view. Detailed calculation you will not did here unless you deal with the quantum mechanics. You will learn the quantum mechanics, and there you can find this experiment is the Davison-German experiment, and another one is the I forget the name. So where you can find this splitting, how it's happened, and detailed calculation you can find there. So I need this splitting point, this degeneracy level. If you understand, that is clear. This is important for my teaching. Now, what will happen to this system that I want to compare? So now you can understand that each energy level n equal to 1, you have the splitted level, and you can count how many electronic level are there. So each
Excuse me,
n equal
sir.
to 1. Yes.
So actually, like there seems to be an internet glitch which happened just now, because of which a lot of students are not connected. So can you just wait for 1 minute or so?
I'll wait.
Like a lot of students just got disconnected, so you might have to go back and repeat a little bit.
Okay, I am waiting. So whenever they join, just let me know. Or I will reconnect. I think there are a lot of students in the class at present. But you just discuss with your friends and let me know when I'll start the class.
So I think it is because of an outage in the internet at our hostel, like since most of us are at campus.
Maybe the local point of problem, not the means the large scale. But
No, but all of the students are in hostel right now, right? At least 90 to 95% of them. So maybe they might be making their arrangements, but I think it will take them like a few minutes more.
okay, so I'm waiting for 5 minutes, and later I'll talk to you. If you have the connection, then I'll start the class. At this moment, I'll stop the class. Okay.
Okay, sir, I'll just wait if I get any more.
Okay. Just to wait, and if you find something.
Excuse me, sir.
Yes.
It appears as if the issue is probably not yet resolved.
Can I start now?
I think like a lot of people are still not able to connect. I've asked them, they are not able to connect. I mean, I'm able to connect since I'm also using my hotspot, but I think everyone else is unable to do that.
So it's a big issue. So maybe I'll wait for another 3-4 minutes and I'll sum up for this class for 10 minutes within 10 minutes. Okay. So I'm waiting up to 6 p.m. and 7 p.m. Then and I'll contact you. Okay.
Okay, sir. Okay.
Okay.
So I think you can start off now itself because I don't think it would make sense to wait much longer. And those who are unable to join, I'll try my best to convey whatever you've taught to them.
Okay, that's good. Maybe next day, maybe a little bit I'll repeat. So this is the starting point. You have to understand the mechanism behind these types of physics. That is most important. If you miss these types of part, then you will not catch my lecture later on. This is the basic point, and this will help you throughout your or study of the semiconductors. Not only it will help you to study later on the other types of solid state physics and other material too. So I think you should clearly understand the phenomena. Mathematics is completely different. So you have to learn a lot of mathematics to understand or to solve these types of exact calculation of this result. But the phenomena, to understand the nature, it's completely different. You have to gain through your own understanding with discussion with us. But the development of the mathematics, this is the additional part you can learn later on. If you don't able to understand the numerical understanding of a subject is different than the mathematical one. You have to first understand phenomenologically, then you can adopt the mathematics to take the exact quantitative value of all those calculations or all this measure for the measurement of those or data. But phenomenological understanding completely different. And if you want to be a good scientist, first you try to understand the phenomena. So later on you can do calculate all those things. Now we are doing a lot of things related to the science, but we predict first what may happen. Then we will try to calculate theoretically and also experimentally. We try to get the result. But if you understand the physics clearly, if you have the understanding level of the phenomena, then you can predict lot of things. This prediction is important. If you understand the physics, you understand the mechanism, then you can predict the experimental result, you can predict the theoretical result. Quantitative value may have some tolerance, but the phenomena you can predict before you do the experiment, before you calculate it theoretically. So try to understand, and here I will build this subject based on this, mostly the phenomenal explanation based on some of the well-known results. So as I consider the Bohr model, I know you understand the Bohr model. So I'll explain. I started from the Bohr model to explain you how this Bohr model is. if you understand clearly the Bohr model, then what will happen later with some fundamental scientific addition of the scientific part, I can explain you how the band gap can be created. So that is very without going to the rather with the bigger mathematical calculation, that is Corning-Krenning model and the tight binding model, that you can learn in your MS level. That is far away from now. Without knowing your quantum mechanical and statistical mechanical knowledge, you cannot be able to calculate those bigger mathematics. But if you understand the Bohr model, and if you clearly understand the Bohr model, I will add some few points on this part, and you can able to clearly you can get an idea that how the semiconductor should be look like, how their energy should be look like, and you can able to understand the science behind the development of the semiconductor devices. So here I want to add this. This is the point. Now you can understand n equal to 1. N equal to 1 have degeneracy of 2 electron can be accommodated. N equal to 2 have 8 electron, maximum 8 electron can be accommodated. So this is 8 level degeneracy. If we just look n equal to 2, energy, all have same energy. Without addition of the magnetic field, all have same energy. This is for hydrogen atom, if you consider this is minus 13.6, then for n equal to 2, you divide it by n square. So you divide it by n square 4. So 13.6 divided by 4 is your value. This is the level. But this energy level, n equal to 1 for hydrogen atom, it is minus 13.6. For n equal to 2, it is minus 13.6 divided by 4. This is the. But here you can you work into 1, you have 2 energy level. It can accommodate 2 electron. It degenerates to 2. But n equal to 2, E2 is minus 13.6 divided by 4. Something you can find 3 point something. So for n equal to 3, you can understand it can accommodate 8 plus 10. 8 plus 10, 18 electron. 18 electron. E3 level is your minus 13.6 electrovolt. All are unitary electrovolt divided by 9. This is the energy level. So if you plot this energetically from lowest level, minus 13.6 electrovolt minus, then you have this is 3 point something electrovolt. Then you have 9 divided by 1 point something, 1.3 or something electrovolt order of. This is minus value. This is the lowest level, deepest level, then higher level are there. But this one have degeneracy of 2. This one have degeneracy of 8. This one have degeneracy of 18. So initially, if you don't apply anything, you cannot see. Only one energy level you can find. But if you apply magnetic field, this will be split into 8 level. This will be split into 2 level. This will be split into 18 level. This is a particular condition. You can see it. You can able to split it. So if we are able to split it by any external or forces or any type, we call it the distortion, or you can say perturbation. In scientific term, in physics term, we call it perturbation. So if we add something additional force, we call it perturbation. To perturb this part, then it will disturb your system and it will give the original individual state or individual without. If you perturb it but it did not split further, then these are the non-degenerate level. We call it non-degenerate level. So this is important thing. Now you can consider if this is such situation is there, then if what will happen. Now I consider this one nucleus is there, then you have first n equal to 1 level. I consider 2 system is there, n equal to 2 level. Further is there, I did not consider in this case. Now you consider another same atom, homo types atom is there, so n equal to 1 and n equal to 2. N equal to 1, n equal to 2 here. How many electron is there? Possibility here 8 electron can stay. 1, 2, 3, 4, 5, 6, 7, and 8. Same should be here. So I'll 1, 2, 3, 4, 5, 6, 7, 8, and here 2 electrons. 2 electron can stay there. So it is clear to everybody that this is just the point of view. So this, if this is the case, so the first is helium, then argon. Helium, argon. So this configuration is for argon. So it will not. This is the field state. You know the based on the chemistry study. You know this. This is the inner. They cannot. This fully filled is fully attracted by the nucleus, so it cannot easily remove this electron, and it cannot easily accept this electron. This is inner. Somehow, if you go some electron where one electron is less, they can gain electron. That is the possibility for the stability of the stability of this atom that will happen. But now simplicity, anything can happen. Now we consider one situation. If these two atoms far away to each other, like gaseous state, argon in normal gaseous state, it is the argon atom. Now, if you push it to close each other, how you can do this? If argon is far away, it's a gaseous state, then these two atoms are far away each other. Now, if you want to make this argon atom close to each other, how you can do it? Can you explain? Or you have any prediction?
We can increase the temperature.
Just one. I cannot hear you. Just yes. Please, can you be little louder?
Sir, can we increase the temperature to make them?
You want to increase the temperature?
Yes, sir.
Are you saying you want to increase the temperature?
Yes, sir.
So, increase the temperature, what does it mean? You know, if you increase the temperature somewhere, you are providing the energy from externally. Am I right?
Yes, sir.
If we add the temperature, temperature is the energy. You are adding the energy. So, if you provide the energy to this atom, what will happen? Whatever the kinetic energy it has, okay, I say the kinetic energy it has something. Now you adding this energy will adapt its kinetic energy. So initially whatever this kinetic energy it have, now you are adding some additional energy. If it absorbs this additional energy, it should have a higher energy. So its velocity will move up. It will increase. It will add its this additional energy will add up its velocity. So they will try to move away to each other. So if we add temperature to the gaseous system, so they try to their kinetic energy or their velocity all will increase. So they try to move away to each other if you are not confined it. So higher temperature means you are give some space that the electron or this atom can move away to each other. This is the process. You have to do opposite one, taking out the energy minus T. Reduce the temperature from the system. Then what will happen? Whatever the energy it has, it will lose it. You reduce the temperature, then the atom tries to its kinetic energy or its velocity will reduce with the lowering of the temperature, and they try to become closer to each other. So if you want to do that these two atoms become close to each other, you want to make one thing we can do, you reduce the temperature and make it as less as possible. If you make it lower temperature, these argon atoms try to couple each other. They may become, and argon can become a liquid in lower temperature, and then you can find liquid formation means the coupling, somehow coupling. This depends on different types of coupling. One is the direct bonding, one is the ionic bonding, one is the covalent bonding, or van der Waals bonding, depending on the situation how they will happen. So they may come close each other if you reduce the temperature. For gaseous system, you know that water is there in vapor state above 100 degrees Celsius. At 100 degrees the phase transition, above 100 degrees purely gaseous state. If you reduce the temperature, that it's become liquid. If you further reduce the temperature of the water, it's 4 degrees Celsius, it become solid. So this phase changes happen because of the higher temperature. Atom move away to each other. If you want to make it closer to each other, then you have to reduce the temperature. This is one parameter you have. You have any other parameter to make it close to each other? Any idea? Anyone? You can just say what about this happen.
Maybe volume reduction.
Volume reduction. Volume reduction means you are applying pressure. That is, you can reduce the volume only by applying pressure. So you have to adapt the pressure. High pressure or low temperature. This is the process to make this molecule, this atom close to each other. Let's assume you are playing with this case. You are reducing the temperature or you are applying higher pressure. Then these two atoms now become close to each other. Let's assume the phenomena such that this orbit now overlap with this orbit. So inter-atomic distance you are now reducing, and something happened that the first orbit, I say this n equal to 2 orbit, now n equal to 1 orbit, maybe they are not overlap to each other in some distance. I am considering this n equal to 1 orbit not overlap, but n equal to 2 orbit overlap. N equal to 2, n equal to 2, n equal to 1, and n equal to 1. So you can see that the first orbit, you have the radius, each of this orbit, you can measure two ways. The energy level, this n equal to 1 or n equal to measure, you can two ways. One is the radius from nucleus to this nucleus. This you can measure. Or this is the nucleus to this distance, you can measure from itself. Another point of view, you can define this n equal to 1, n equal to 2 by this energy level. This minus 13.6, minus 3.6, and 1.3. This way, for different atom, for hydrogen atom like this, for other atom it should be modified. But you can measure this way. Two way you can measure this energy. One is the by the radius. You know this radius? Okay, this is the distance between this. This is one of the measurement of this orbit. Or other way, you know the energy of this state. So you can measure this is the energy level. So you can define it from the how much the energy required to remove the electron from here to the outside the attraction of this atom of this nucleus. It's called this free energy. So you can remove this electron, that this cannot return back to this original position at this n equal to 1 level. That is the amount required to remove the electron from the attraction of this Coulombic attraction of this nucleus. That's minus 13.6 electron. So you can measure by this orbit or this energy level. Now you consider these two orbit n equal to, that is minus 3.6 around, I just consider these two orbit now overlap to each other. So physically that means this n equal to 2 radius, this if I say R2 level, this R1 radius, this R2 radius now overlap to each other. R2 radius overlap to each other means physically they contacted these two, this orbit is contacted to each other. If you consider you have football, one is the bladder inside and outer cell is the football outer layer. So now you want to close each other. First thing what will happen, minimum distance, what is, it can touch to each other. Two football can touch each other. If we reduce further, because in football is solid, but it is not solid, it can enter inside this part. So minimum it can touch or it can enter in this outermost part. What will happen? Energetically, if you think this is minus 13.6 electrovolt, two atom is here, and this one is minus 3.6. Just I am overlapping. You can find the exact value, 3.6 electrovolt. Now you can check these two orbit n equal to 1 are not overlapping to each other. So they remain as it is inside the your original identity. If I draw the actual orbital structure, you can draw something like this. So here you can consider the other orbital. So I can remove this part. So this part you can understand. The inner orbit, inner part, if I say mark is the, this is the orbital radius. This is the orbital radius. They are not interacting. But here you can consider the upper part, the both orbit now overlap to each other. So they are interacting. What does mean by interaction? You can say electron from here, it can go to here. That is no barrier should be there. This is one issue. But another point of view, degeneracy point of view, if we consider this level, this level only accommodate 8 electron, and this level only accommodate electron under magnetic field. Without any interaction, this will remain same. So if you think this is to happen as per the Pauli exclusion principle, this 3.6 electrovolt should not accommodate more than 8 electron, because other 8 electron accommodated by the degeneracy. You apply magnetic, they will be splitted. So each 8 level it should be splitted. You can consider this splitting here also 8 level under magnetic field. Now even you can see this lowest level now accommodate 2 additional 2 electrons at same level. But as per the all the principle, if you consider quantum mechanical principle, not more than 1 electron can sit in the same energy level. So what will happen? They will try to fight each other. Just physically, if we say two, you have only one sitting position, you have one sitting position, both have same energy. You say sit, one can sit here, other. But who will win? Who will sit in this position? Who don't win? They have to go to the other position. So these two level try to fight each other. Something the scenario is there. So they will try to interact each other. One energy level move up and one energy level going down. So this is something fighting. This is due to the electron additional. What is happening here? To know this electron and this electron will repel each other. These two electron of this atom and this atom try to even additional Coulomb attraction is coming here. So due to this process and the other part, the attraction of this atom, this nucleus to this one, and this nucleus to this electron will happen. But the electron repulsion and nucleus repulsion will happen. Ultimately, what will happen? They try to give some way one electron going lower energy level, one electron moving to other energy level. This is the under the field potential. So they will split each other, and this degeneracy will remove, and still it remain as a following the Pauli exclusion principle. So each energy level will split into 2 energy level. Is it clear to you now?
Yes.
Okay. So this splitting is very important, because of this is, if you want to calculate, then you have to calculate this additional potential energy. So if you know this potential energy, you study this one in quantum mechanical formula. I will explain little bit in the next class how to calculate this one. So you have to add this in the additional potential, you have to add up in this potential and this normal Coulomb interaction. You have to add the additional potential, then you can find the exact value of this calculation. But from here you can understand that due to the you can just assume that this interaction, Pauli exclusion principle, cannot be breakable anywhere for the fermionic particle. This electron, I'll explain what does it mean by fermion and what is the boson. For electron types particle, it will never break this Pauli exclusion principle. They follow the Fermi-Dirac statistic. If they follow Fermi-Dirac statistic, they never break this principle. There are other particles that is called bosonic particle. They will sit more than one electron can sit the same energy level. Those are called the bosons, Bose particle, or that theory developed by Professor S.N. Bose and the Professor Einstein. So Einstein and Bose, that is called B statistics, Bose-Einstein statistics. And the other one is called Fermi-Dirac. The Professor Fermi and Dirac, they developed this theory that's called Fermi-Dirac. So whole of the world divided into 2 types of particle. One is the Fermi-Dirac particle, another are the Bose-Einstein particle, generally known as Fermi particle and the Bose particle, by honoring the name of the boson. So S.N. Bose, Satyendranath Bose, the famous Indian scientist who developed this theory. So Bose-Einstein statistics they follow, but electron is the Fermi particle. It has the spin half integer particle, spin half. As I say, ms value is half integer, half, or if it's a half or 3/2 and 5/7. These are the spin half. Those particles we call the spin half particle, and those some types of other particle is like photon. The spin value is 1. So some particle we have spin 1. Those particles 1, 2, 3, etc. So integer multiple of the spin. Those particles have to follow the Bose particle, boson, Bose statistics, Bose-Einstein statistics. We call the bosons. So these 2 types of statistics is there. So it never be broken. You now at this moment you can just you have to adopt that this is the principle of the nature. The Pauli electron cannot be violated by any Fermi particle. So electron is a Fermi particle, so it cannot violate it. So that's why it have to somehow it will fight or it interact. Due to this interaction, they will split into two additional and two energy levels. So one will going down, that we call the bonding state. We have the lower energy, we call the bonding state. Bonding. The other is called the anti-bonding state. Yes. From here, next day I will try to build how the band can be created, and then I'll add up the more on this get how to study the semiconductor like silicon, germanium, what will happen, or other types of compounds, semiconductor, what should be the features, and I'll explain you one by one the phenomena, and little bit small mathematics I will do to understand the mechanism. You can able to calculate if you understand this mathematics. It should not be very complicated mathematics. Based on the basic sum assumption, I'll treat this mathematics, and then you can able to understand. You can own yourself. You can able to calculate how many electron can sit in the conduction band, how many electron can be in the valence band, etc. You can able to calculate, and that calculation will give you the idea to build a junction. If you want to build some junction, how many electron can move one side to the other side, and so on. That mathematics is very important, and for simple assumption I'll try to calculate those mathematics, and from that you can understand better the semiconductor devices without just following the normal that you are getting some current and voltage, then this is the analog electronics. I don't want to teach in this manner. You can by yourself you can calculate what should be the IV characteristic, what should be the characteristics of the device. You can able to predict from those mathematical. So let's stop here. If you have any queries, you can ask me now.
Yes, sir.
Okay, so let's stop here. So best wishes from my side, and you should try to read this these classes.
Thank you, sir.